Welcome everyone to Algebra 2, Section 1.5, Solving Systems of Equations by Substitution. So we're still doing linear functions like we were in sections 1 through 4 of Chapter 1. So you guys are going to be able to solve these linear systems of equations by substitution today. So our warm-up problem, a test has 20 questions worth 100 points total. The test consists of true-false questions worth 3 points each and multiple choice questions worth 11 points each. No thank you, don't want to update that now. Set up a system of equations to solve. How many multiple choice questions are on the test? Alright, so one good thing I always like to do when I see a word problem is underline some key information. So the fact that it has 20 questions is good to know, and that it's 100 total points. We know we have true-false questions that are 3 points each, and we know we have multiple choice that are 11 points each. So we know we're going to set up a system of equations. You can choose whether or not you want to underline that. And the question we want to answer is how many multiple choice questions there are. So that means if that's what we want to know, that's going to be one of our variables, is representing the number of multiple choice questions. So I'm going to call that m. So I'm going to say m is equal to the number of multiple choice questions. So if one variable is the number of multiple choice questions, the other variable is likely to be the other type of questions. So I'm going to call it f for true-false questions. And you might be wondering, Mr. Cross, why didn't you just choose t? Well, I would, except for t often looks like a plus sign. Even if you write the little tail, it can get confusing. So I try to avoid the variable t if I can. But sometimes we still use it for like time or something. All right, so now as we actually do the system, one thing I always want to note in systems of equations is looking at labels. And what I mean by that is saying 20 is the number, 20 what though? Questions is a label. 100 is the number, points is the label for that though. So 100 what? Oh, it's 100 points. 3 is the number, and points is the label. 11 is the number, and points is the label again. So we have 3 of the same exact label, points, and 1 of the label, questions. So anytime we have 3 of the exact same label, and it's exactly 3, not more, not less, those are more than likely going to go in the same equation, and that's true here. So we're going to do something akin or alike to having 11 and 3 combining to be 100. And the reason I say combining to be 100 is because this is the total amount. So we know we're going to equal 100 because it's a total, and to get there we're going to add up. Now if you just take 11 plus 3, you're not going to get 100, you get 14. So that's where the variables come in. So 11 points for the multiple choice questions, M, all right, 11M, and 3 questions for the true-false questions, which are called F. So we have 11M plus 3F is equal to 100. So this is talking about 11 points plus 3 points per question is equal to 100 total points. Now we still have the number 20, so that's going to get used in this next equation. So that's another total number because the number of multiple choice questions and the number of true-false questions added together are going to get us the total number of questions 20. So we're going to take exactly that. M for the multiple choice questions plus F for the true-false questions gives us 20 total questions. So the second equation ends up being questions plus questions equals questions, where the first equation was points plus points equals points. So the labels stick together. Now we have to come up with, well, how are we going to solve this equation, okay? And that's actually what we're going to be talking about today. But you might remember from a previous class, like Algebra 1, of how to solve this. And if not, you can always do some guessing and checking and saying, well, maybe it'll be 5 multiple choice and 15 true-false, because that adds up to 20. Or maybe it ends up being 10 of each, or 12 multiple choice and 8 true-false. I'm going to actually use the substitution method here that we're going to be talking about today in the lesson. So in order to do this, I'm going to solve one of the equations for a variable. So I'm going to pick this bottom equation. I'll talk about y later. And I'm going to solve it for f. So to do that, I'm going to subtract m on both sides. And that gives me, as I point to my arrow over here, f is equal to negative m plus 20. So now, since f is equal to that, it's the same thing as that. So I'm going to take all of this and plug it in, excuse me, not for m, but for f in the other equation. And that'll give me 11m plus 3 times my new f, which is negative m plus 20. And that'll equal 100 to finish off the equation. And now this is an equation we can solve. So I distribute my 3 and get negative 3m plus 60 equals 100. Combine like terms, and I get 8m plus 60 equals 100. Then I'll subtract 60 from both sides and get 8m is equal to 40. Now as we divide by 8, we have, hey, there are 5 multiple choice questions. And really, we're actually done here. Because if we notice, the question was just asking how many multiple choice there are. Well, there's 5. Now, we can go back and find out by plugging it in how many true-false questions there were. Because, well, if they add up to 20 total, that means 5 plus the true-false questions has to equal 20. Subtract the 5, and there's 15 true-false. Once again, we technically weren't asked to find, but we could find it there. All right, let's actually get into the notes now. So one of the questions we asked in 1.4 is, can solving by graphing always provide an exact answer? And sometimes it was kind of a mess. So we can use algebra to solve these systems of equations as well. And there's 2 methods for that. So one is substitution, which we already just actually did up above for the warm-up. And the other one is elimination, which we'll learn next lesson. So there's going to be 6 steps we're following here for substitution. So the first step, solve one of the equations for one variable, which is what we did up above. We solved the bottom equation for f. Second step, substitute this expression, so in this case it was the negative m plus 20, into the other equation and solve for the other variable. So what that means is, hey, in our warm-up, I solved for f, and then as I substitute into the other equation, we then solved for m, the other variable from what we solved for the first time. Step 3, substitute variable from step 2 into an original equation and solve. So step 3 is what we did once we got to this point right here in the warm-up problem. And then we continued to solve and got a variable as m equals 5. Excuse me, that was step 2. Then step 3 was when we plugged it right back in here, in one of the 2 original ones. We chose the bottom one. And we found the other variable. Step 4 is actually one we didn't do for that problem because it asked a different type of question. Step 4 is write your answer as an ordered pair, which is typically what we'll do. We don't always have to do that for word problems because they're going to be asking more specific questions, such as how many of this type of question are on a test. So then step 5, check your solution, which I'm never going to 100% require you to do that, but it's always an option available to you. And what that is it just allows you to know whether or not you got it right. And then step 6, classify the type of equation we have. So that would be like the consistent or inconsistent, and if it is consistent, if it's dependent or independent. So if you recall, an equation was consistent if it had a solution, or at least one solution, I should say. It was consistent if it had at least one solution, and it was inconsistent if it had no solutions. Now, if it was consistent, it was either independent or dependent. Independent solutions, or independent systems, had exactly one solution, whereas dependent solutions had infinitely many. All right, let's go through some examples here. So example 1, 2x minus 3y equals 16, and y equals negative 5. So step 1, solve one of the equations for one variable. We actually already have this done because this bottom equation already has y by itself. So now we can go on to step 2. Substitute this into the other equation. So substitute y equals 5 in the top equation. So we're going to get 2x minus 3 times negative 5 equals 16, and solve for x. So 2x plus 15 equals 16. Subtract the 15 and get 2x equals 1. Divide by 2, and x is 1/2. Then we're on to step 3. Substitute it into one of the original equations and solve. Now you might actually notice though, we don't need to. If you don't notice that is okay. Let's say we don't notice that. So we plug it back in, 2 times 1/2 instead of x minus 3y equals 16. Well, 2 times 1/2 is just 1, it's half of 2, minus 3y equals 16. Subtract 1 from each side, and you get negative 3y equals 15. Divide by negative 3, and y equals negative 5. And the reason I was saying you might realize, that you don't need to plug it back in is because we're already told y is negative 5. That's already solved. Now we write our answer as an ordered pair, x comma y. So 1/2 comma negative 5. And once again, step 5 is to check your solution, which you always can, but I'm not going to require you ever do. And then step 6 is to classify. So it had exactly one solution, so it is consistent since it had a solution. And because it was only one, it was independent. And maybe a good way to remember that, of whether or not it's independent or dependent, is independent, the I kind of looks like a 1. And so that can help you remember that it's exactly a one solution. Example 2, 5x plus 3y is equal to 1, and negative 4x plus y equals 6. So this one we're not as lucky as on the first example because we don't have the variable by itself already. So we're going to have to solve for a variable first. So meaning we're going to have to get it by itself. So of all of these, we're going to have to pick which one do we think would be the easiest to get by itself. Now, there is one that of these 4 variables, and by 4 I mean the first x, first y, second x, second y, that will be much easier than the rest of them. So let's talk about why that'd be the case. So let's start off with saying, hey, would this first x be easy or not? And we're going to go through all 4 variables. So this first x, if we solve for that, our first step would be subtracting 3y from both sides. I would not write any of this down, by the way. Don't write any of this part down until we actually start solving the equation. 5x equals negative 3y plus 1. Well, now we divide by 5. And we're going to get fractions there. We're going to get negative 3/5 y and 1/5. I would not want to deal with fractions. So let's say maybe we try not to do that one. Okay, well, let's say we solve for this y. Well, similarly, our first step would be to subtract 5x. And we'd end up with 3y equals negative 5x plus 1 and divide by 3. Once again, we're going to get fractions here with negative 5/3 and 1/3. Not ideal. So let's try a different variable. So let's try the bottom x. So our first step would be subtracting y. And you get negative 4x equals negative y plus 6. So then we again have to divide by negative 4 and giving us fractions like 1/4 y and negative 3/2 as 6/4 reduces. Once again, not ideal. Well, last but not least, let's try that second y. So our first step here would be to add 4x to undo this, the negative. And we'd have y equals 4x plus 6. And that's actually already by itself. So that one is going to be our easiest option by far. And how you could identify that right away is saying this has a coefficient of 5, this has a coefficient of 3, this has a coefficient of -4, this has a coefficient of +1. So anytime there's a coefficient of +1, or the next best thing would be a coefficient of -1, that is going to be your best choice possible. So going back to our warm-up, I chose this F. Well, this F or this M in the second equation would have both had a coefficient of 1, and so would both be great options. I would not have wanted to choose the first M or the first F because they have a coefficient of 11 and 3 respectively. Go ahead and write this part down. So maybe pause the video, write this down, and I'm going to keep going with this problem. So we're on to step 2 since we solved for a variable. We got y by itself. So now I'm going to take this y equals 4x plus 6. The 4x plus 6 is going to go where y is. And we're going to get 5x plus 3 times the quantity of 4x plus 6 equals 1. Distribute the 3 and get 12x plus 18. Combine like terms to get 17x plus 18 equals 1. Subtract 18. 17x equals -17. Divide by 17. X is -1. So once again, once we substituted in the 4x plus 6 for y, from there, it was just solving the algebra equation, which we have done so many times. Doesn't mean we'll never make a mistake, but we've done it enough times to know what we're doing. Now we're on to step 3. Substitute it into one of the original two equations. So you can pick whichever one you want. I'm going to choose the bottom one, just because it still has that coefficient of +1 with the y, so I like that. So -4 times -1 plus y equals 6. So everything stays the same except for x this time is replaced. So -4 times -1 is +4 plus y equals 6. Subtract 4 and you get y equals 2. Now we have our system, our ordered pair, -1, 2. And it was exactly one solution, so it is consistent because it had a solution. And it is independent since it was exactly one solution. And remember the I kind of looks like a 1 there. All right, we're going to have 4 more examples here for the notes today. Example 3, y equals 2x plus 8 and y equals -3x minus 2. So maybe a good thing for you to do would be to start off this problem by yourself and see how far you can get, pausing the video. On this problem, you might notice that both equations are already solved for y, which is super nice. So we can substitute either one into the other one. And whichever one we choose, it won't affect it at all. So let's say I substitute the -3x minus 2 in for the y in the top equation. So I get -3x minus 2 is equal to 2x plus 8. If you had substituted 2x plus 8 in the bottom equation instead, the only difference would be your equation would look flipped from mine, which is the same exact thing. Now we're going to add 3x to both sides. You could do a number of steps here. That's the step I'll choose. -2 is equal to 5x plus 8. Then I'll subtract 8 from both sides. Get -10 is equal to 5x. And divide both sides by 5 to get x equals -2. Now I can plug it into either of the original two equations. I'll choose the bottom one. It really doesn't matter. And you'll probably develop preferences as you continue to work with these of saying, I'd rather use the top one in this scenario or the bottom one in this scenario. That's totally fine. Y equals -3 times -2 minus 2. So -3 times -2 is +6 minus 2. So y is 4. And you'd have gotten the same answer had you plugged it into the top equation. So our ordered pair is negative 2 comma 4. We have exactly one solution, so it is consistent because there was a solution at least, and it is independent because there's only one solution. Example 4 here. Oopsie, sorry about that noise. 5x minus 3y equals 2, and x equals negative 2y plus 3. Once again, might be a good idea to pause, try this one on your own as far as you can get, and then continue with the video. So here we have a variable by itself. It's not y this time, it's x, and that's perfectly fine. We'll just take negative 2y plus 3 and substitute for x in the other equation. So 5 times negative 2y plus 3 minus 3y equals 2. Distribute to get negative 10y plus 15 minus 3y equals 2. Combine like terms to get negative 13y plus 15 equals 2. Subtract 15 from both sides to get negative 13y equals negative 13. Divide both sides by negative 13, and y is positive 1. Plug back into either equation. I'm going to choose the bottom one because the numbers are smaller, as well as the x is already by itself. X is equal to negative 2 times 1 plus 3. Negative 2 times 1 is negative 2 plus 3, which is 1. So answer this one is 1 comma 1. So that's consistent since there was at least one solution, and it's independent because there's only one solution. Because the I kind of looks like a 1. 2 more examples left here. Quick recap though of what we've been doing. On the last 2 examples, we've been fortunate enough to have a variable solved for already in at least one equation. So we're able to plug that in to the other equation, distribute and solve, and then plug it into one of the original equations to solve for the other variable. But however, on example 2, we were not so fortunate. So we first had to solve for a variable, which we said to choose one with a coefficient of positive 1 if you can. If not, well, then maybe choose a number that divides into all of them. So I'll use number 5 as an example here. Number 5, we have a variable solved for already. Let's say we didn't, okay? Let's say we had to solve for one of these 2 variables, and we had to pick one of those. For some reason, we're forced to pick one, because some systems you'll be given won't have a nice, easy option with the coefficient of 1. I would pick this one over 6x. The reason why is that to solve for either variable in the equation, as I trip on my words there, we'd have to subtract the other variable, so whether that's subtracting 2y or subtracting 6x from both sides, and then divide by the coefficient. So as I'm thinking through this, would I rather divide all 3 of these numbers by 6? Or would I divide all 3 of these numbers by 2? And I would much rather divide each of those numbers by 2, which would happen if I solve for this y, because I would subtract the 6x, don't write this down, and then I divide by 2. So it still has to divide, but there's no fractions, so it's not too bad. Now, once again, we don't actually have to do this on this problem because we do have a variable solved for already. We do have this y already by itself. So this might be also a good problem just to pause, work through as much as you can, and then continue on with the video. So I'm going to take this negative 3x plus 1 and plug it in for y, and get 6x plus 2 times negative 3x plus 1 is equal to 8. 6x plus negative 6x. From there, we're going to combine like terms. 6x and negative 6x give us 0, so we have 2 equals 8. Wait a second. 2 will never, ever, ever equal 8. This is no solution. So anytime you get an equation that's not true, and it'll never be true, like 2 is equal to 8, there's no solution. So this system is inconsistent. So we don't have to worry about saying is it dependent, independent, because that only happens if it's consistent. So once again, we had a variable by itself, we plugged it in to the other equation, distributed, started simplifying and solving, but then we got an equation that wasn't true. Now, if you were to get an equation that's always true, like maybe you were to get the equation 2 equals 2, well, that would be IMS, and that would be consistent and dependent. On to example 6, a word problem. I think it'd be a good idea to pause the video and try and underline some key information on your own. That's what I'm about to do here. All right, so this mayoral election, number of votes for the incumbent was 25% more than the number for the opponent. So the incumbent was 25% more than the number for the opponent. Probably good to know. Altogether, they received 5,175 votes. And we want to know how many votes did the incumbent receive? All right, well, we're probably going to have a system of two equations. Let's figure out what at least one variable is going to be, and let's just use x and y for variables. Well, one variable is always going to be related to our question. That's what we're finding. So how many votes did the incumbent may receive? So I'm going to have x represent the incumbent. So you might be thinking, well, what would y be? Well, it'll be the opponent. I'm going to shorten it to OPP because I'm lazy. So now we need to make a system of two equations from this. So we know that together they received 5,175 votes. So in order to get to that 5,175 number, they'd have to add to get there. So I'm going to do x plus y. The number of votes for the incumbent plus the number of votes for the opponent are going to get that total number of votes. And then we're also told that the number of votes for the incumbent was 25% more than the number for the opponent. So what we're going to do is we're going to take the incumbent, I'm going to say was, we're going to say that's really is, or like equal to 25% more, meaning that's really 1.25 times y. Now the reason that's 1.25 times y rather than 0.25 is if you take 0.25 times something, 25%, that makes it smaller. But what we want is we want the whole already, so that's 100%, and we want 25% additional. So we want really 125% of what the opponent got, because that gives us the 100% of what the opponent got, so all of their votes, plus 25% more, giving us 125%. So we move the decimal over twice, hence getting that 1.25. That then gives us a system of equations we can use. And we actually already have a variable by itself. So real quick, how I got this system before I start solving is I said, hey, one of the questions is how many votes did the incumbent receive? So we're probably going to have, we're going to have one variable represent that. So x is going to represent incumbent, I said. Then y will represent the opponent, the other candidate. We knew they had 5,175 votes total. So we said, hey, x plus y, the two candidates together, got that many votes. Then the other equation, the incumbent was, aka equal, 25% more than the number of the opponent. So here's the opponent, and to get 25% more, once again, we said we have to get the 100 original percent of the opponent plus the 25 extra to get 125% of their vote, which then, as a decimal, becomes 1.25 as you move it over twice. So now, actually solving this, we have x by itself. So we're going to take this 1.25y and plug it in for x. So 1.25y plus y is equal to 5,175. Combine like terms and get 2.25y is equal to 5,175. And just because there's a decimal, it won't change what we do. We're still going to divide by 2.25 because it's multiplying with y. And thankfully we have calculators to say, hey, 5,175 divided by 2.25 is 2,300 votes for the opponent. What we really want, though, is how many votes the incumbent received. So we can plug it back into either equation. Let's say we choose the top one. You can choose either one, like I said. X plus 2,300 equals 5,175. Subtract 2,300 from both sides, and X, the incumbent, received 2,875 votes. So the system is consistent and independent, but we're not asked to classify that. We're just asked how many votes the incumbent received, and we found the answer to be 2,875. If you had plugged 2,300, the opponent's votes, into 1.25y, you'd get the same answer. That is it for these notes. Please go ahead and work on that 1.5